Now we see the parametric equations of a circle. Now by parametric equations we mean, instead of considering the coordinates of any general point as x and y, which are two unknowns, isn't it? Won't it be nice if we have a single unknown to deal with, and that is what we call as a parameter, right? So now here, if you observe that, let us consider the angle made by the radius CP with the horizontal direction as theta, okay? And if we drop a perpendicular from the general point P to that corresponding horizontal line, we see that the difference along the horizontal direction is nothing but x minus h, and the difference along the vertical direction, that is along the parallel to y-axis, is nothing but y minus k, right? So therefore, in the triangle, if you see that small triangle formed, we can write that cos theta is nothing but x minus h upon r, and sin theta is equal to y minus k upon r. So therefore that gives us x minus h is equal to r cos theta, and y minus k is equal to r sin theta. So therefore finally, if we take h and k on the respective right hand sides, we get the final expression as x is nothing but h plus r cos theta, and y is nothing but k plus r sin theta. So these are called as the parametric equations. So what it means is, we can consider the coordinates of point P as h plus r cos theta, comma k plus r sin theta, in which we have a single variable which is theta, because h, k and r are the given arbitrary constants. Now let us see one example based on writing the parametric equations. Find the parametric equations of the circle whose equation is x square plus y square minus 6x plus 8y equal to 0. Now let's keep ready the parametric equations which we just derived. The formula for them is x is h plus r cos theta, and y is nothing but k plus r sin theta. So that means we must first find out h comma k, that is the center and the radius of the given circle. Now looking at the equation of the circle, we immediately recognize that it is in general form, isn't it? So comparing with the standard form, here we have 2g is nothing but minus 6, so therefore g is nothing but minus 3, and comparing the coefficient of y, which in the original equation is 2f, since that is equal to 8, so f turns out to be 4. So therefore center, since it is nothing but minus g comma minus f, we have to merely negate the values so obtained, so that turns out to be 3 comma minus. So we have obtained the center of the circle, which is nothing but h comma k, correct, which we will plug in here. And we have to find out now the radius. Radius is given by root of g square plus f square minus c. Now since there is no constant term here, c is nothing but 0, so therefore radius is nothing but, g was minus 3, so minus 3 the whole square, plus f was 4, and here we have 4 square, so we have 9 plus 16, which is 25, and hence its root is 5. So the radius turns out to be 5. And so finally we write the parametric equations by substituting x is equal to h is 3 plus r cos theta, which is 5 cos theta, and y is equal to k, which is minus 4, plus r sin theta, which is 5 sin theta. So these are the required parametric equations of the given circle.